Hey, Mr. Thompson here today, even though I'm not with you. Little video, I'm going to feel weird because I'm going to be under the dot cam, not with my beautiful face in front of you. So just follow along in your notes, take some notes. We're going to talk about translations today, and a translation is just the sliding of a shape in a specific direction, a specific distance. So take a few notes. I think you'll find this relatively user-friendly. All right, hopefully you can hear me, even though you don't see me. They all said I had a radio voice. I'm not sure what that means, but here you go. If we have a triangle, and we'll just call it A, B, C here, just for the sake of talking, and we want to translate it along a given vector, all right? All we're doing is we're sliding this triangle, the length of this vector, and that's just an arrow, okay? It's just a distance and a direction, so we're sliding it down and to the right. So here's what we're going to do. We're going to make parallel lines through points A, B, and C. Okay. Not only do we make three parallel lines, we make them all parallel to the given vector. We're going to kind of eyeball it, all right? So all we're going to do is we're going to be like, all right, line your protractor up so it looks like it's going to produce a parallel line, and then we just zip her down. Okay. So if you look, those two lines are pretty parallel. And then we just continue that pattern, okay? Now we put our protractor so point A is on the flat part, and we just kind of tweak it around until the base of that protractor looks parallel to what we've already done. Zip her down. All right. And one last time through point C, we look at that protractor, make sure it's parallel to our other lines we already have in the given vector. And again, we're eyeballing it. I'm giving room for error, but we should be fairly parallel, and zip it out. Okay. So far what you've done is you've shown that by making these parallel lines, all 3 points, A, B, and C, are going to be translated or moved the same direction as our vector. The second piece of translating is distance. We have to make sure we preserve distance. So what we do there is we now just copy the vector's distance. In fact, I'm a big fan of using a slice of paper, putting the corner here, in the end of the arrow here. So I need to translate each one of my points this distance. So watch how slick this is. We just move that distance down, put B on one end, B prime ends up, the same distance away, and that length represents that of the vector. And then we continue that, copy that distance. Okay. All right, scoot that down, corner of the paper on A, our little mark here, now we know where A prime goes. And lastly, we do the same thing with C. We're just copying that distance. Put our little corner mark on C. End of the vector is where C prime goes. And there you go. You have translated. In other words, you have slid your triangle to its new position. By the way, if you don't like that paper idea, you are more than welcome to use a measuring device. You could measure your vector and say, oh, that's 3 1/4 inches long. Slide down here, and guess what? Go 3 1/4 inches, boom, put a dot. All right, the other way we're going to look at translating objects is through some rules, okay? And as long as you feel comfortable with counting up, down, left, and right, this is a slick, easy little task. On the next problem set here, the directions say graph the image under the given translation. 3 units left, 2 units up. Okay. All we're doing there is we're literally taking each vertex and we're going 1, 2, 3 to the left, just like the directions say, 2 up, and there you go. You got yourself your new Z position. And then you do that with each point, L. 1, 2, 3 left, 1, 2 up. L prime. H, 1, 2, 3 left, 2 up. There's H prime. And last down here, B, I'll do this for my Spanish friends. 1, 2, 3, 1, 2. And you have B prime, and you have just translated your shape 3 over 2 up. And sometimes you'll see this funky notation where they have a coordinate like x minus or y plus. It's the same thing. We know x coordinates move left and right on the x-axis. We know y coordinates move up and down just like the y-axis. So when we see x minus 2, what that's telling us is take every coordinate and move 2 to the left. Minus is a negative direction. So it's the same thing. 1, 2 to the left. Now, the number that goes with the y value, y plus 4, that tells us how far up or down to move. A plus is a positive direction, so now we would move 4 up. 1, 2, 3, 4. And this is where W prime goes. So once again, whatever number is with your x coordinate, that's how far left or right you move. Negative is a negative number, or minus number is a left direction, so 1, 2 left. Whatever number is with the y value is the upward or downward motion. Plus 4 is positive. So this again, 2 left, 1, 2, 3, 4 up. In every one of these coordinates, you can move 2 to the left, 4 up. And what you end up doing is you find out and you have translated your original shape to its new position. Not bad, hey? I shouldn't say last but not least, but the only other thing I can think of that would be goofy is, well, what happens when you look and their x doesn't have a plus or minus a number, or the y doesn't have a plus or minus number? How the heck do you deal with that? That just means you don't move left or right. Okay, that doesn't mean, it means you don't move up or down if it was with your y's. So in this case here, we'd look and say, well, our x's aren't being affected, so we don't need to move anything left or right. But our y's, they have a plus 2. So all it's saying is every point in this translation, because the x isn't being affected, just moves 2 spots up. And those then would be your 4 new coordinates for your shape, for your quadrilateral. Hope this hasn't been too crazy so far. We'll look at one last set of values. How in the world, or one last set of values, how in the world do you write a rule? Well, writing a rule, we'll use our arrow notation, is exactly what you just did in the prior 2 problems. We're basically filling this in. We're seeing, do we add or subtract anything from our original point to get to our new image point? All right. Here's our new point. Our original point will always be xy. Arrow symbol tells us we're going to transform it. And we'll have an x with a space there, comma, and a y in the space. And we're just filling those in. So we'll look. Remember, our original point doesn't have the apostrophe. So we'll look at this point in D as our original. Now, let's first start with, do we move left or right to get to D prime? Well, it looks like we move to the right. So the question, that's going to be a plus. Moving to the right is a positive motion. Now, how many spaces do we move to the right? 1, 2, 3, 4, 5, 6. Oh, you're halfway done with your rule. Crazy. What about, do we have to move up or down at all? Well, yeah, if we're going to go from D to D prime, we're not there yet. We've only moved 6 to the right. We still have to go down 1. Well, down 1, down is a negative direction, so we would put a -1 there. And this would represent your rule. answer the questions that follow on the Google form, see how you do. And Mr. Williams will hand out a nice worksheet for you guys to work on in class today that involves some of these problems. I gotta show my face once more. See you Friday.